Okay, here we go. So in this assignment, this is not a super long assignment. You have to do only 5 problems in this one. And as is the case with most assignments, if you understand exactly what you're asked to do, then it shouldn't be too difficult to attempt. This is one of those assignments that's on the slightly easier side. So I hope you won't have a lot of trouble doing this. So let's begin. Question 1. I don't know how many of you got a chance to read it, but if you haven't, I'll just quickly go through it with the question. So in problem 1, you have to write a function called induction plot. I'll just take questions at the end, okay? So write a function called induction plot, and this one has 3 inputs, okay? So there's f and 1, then there is f and 2, and then there is n, okay? So these are the inputs, okay? And the outputs to this one are tf, a logical value, val1 and val2, which are double arrays, okay? So let's understand what each of these inputs and outputs do, okay? So f hand 1 and f hand 2 are basically function handles. Now, each of these functions basically takes in a number as an input, so like 1, 2, 3, and outputs the value of that function at that number, okay? So it's just a simple function. You're given 2 examples in the PDF, so you can look them up and see how to write those functions. And n is the number of integers from 1 to n that you have to test for which whether f and 1 equals f and 2. So you have to, n is, so the maximum number of integers starting from 1 for which you have to check if the function values match. Okay, the function values from 1 until n. So this problem basically you're sort of making a proof of induction, but it's not a complete proof because you're going to check only for a finite number of values of integers, and that's the best you can do with computers in a finite time. So these are the inputs. Now let's look at the outputs. The outputs are, the first one is TF, and that is basically a logical true or false output. So it basically you have to set it to true if the function values match, f and 1 values match those of f and 2 for each integer from 1 to n, okay, and false otherwise. Then the next 2 output arguments are val1 and val2, which are basically the values of the functions evaluated at each integer from 1 to n. Okay, so these are double arrays, both of them, of length n. Okay, so this is the basic description. Now all you have to do in this is basically, so what do we have to do in this? We have to basically evaluate f hand 1 and f hand 2 at different integers from 1 to n and check their values. If they're equal, then as long as they're equal, you set tf equal to true. If for any one of those values, if any one of the values from 1 to n, if the value of f hand 1 doesn't match the value of f hand 2, then you set tf equal to false. So the problem itself suggests the algorithm to do. So what you have to do in this one is basically evaluate f han 1 and f han 2 for I equal to 1 to n. Okay, so here you can use a for loop if you want, or anything else. You can do it in a different way if you want, and store the results in the double arrays val1 and val2. Okay, and then for each, and then check if val1 is equal to val2. So if val1 is equal to val2, then TF is true, otherwise it's false. So it's a very straightforward problem, and nothing much you have to do in this one. Okay, moving on to problem 2. In this one, you're given a function rec factorial. So you're given the code for the function, and you are asked to first find out what happens when you evaluate it for a given number, say f equal to rec factorial 5, and see what happens. So you'll see that it doesn't work, and MATLAB will give you some kind of an error, which you have to write, which you can write in your script file in a comment. But the thing you have to do is basically figure out why it doesn't work. And so you're expected to get an error. You're not expected to get an answer here. So you have to figure out why it doesn't work and then correct it so that it works. So the only hint I can give here is think about what happens when you do when the input to rect factorial is 1. Okay, that should get you going, and it's really easy to figure out what's going wrong and what you can do to change it. So there's nothing much to say for this one. Again, a not very difficult problem. In the third problem, you're given a function called GCD E7, and the way it's set up right now, it works only for positive integers. So what you have to do is generalize it so that it works for any integers, positive, negative, 0, or whatever. Okay, so the main thing you have to do here is basically separate out the cases. So there are basically 4 kinds of cases, right? So 4 cases. So first one, both positive, in which case you don't have to do anything because the given code is written for positive integers, so you're all good. Second case, both negative. In this case, you can just convert or take the absolute values of the 2 inputs and proceed as before. Okay, so it's the same as the first one, you just take absolute value. Third case, actually I should say probably just 3 cases, because the third and fourth case are similar to each other. So one uh, actually let me just put 4 for now. So both positive, both negative, then maybe you can actually combine this case. So another case is that, say, one is 1 negative and 1 positive. Okay, so in this case you can just take the absolute value of the negative input and then proceed as before, so that both are positive. Okay, and the last one is when one of the numbers is 0. So in that case, if one of the numbers is 0, then the GCD is basically the absolute value of the other one. So you just say GCD in that case is absolute value of the other input. And finally, the last case, so there are 5 cases actually, is when both are 0. In this case, the problem tells you that you should set your GCD equal to 0. So in this way, you can analyze the cases and then just use the given code, add on to the given code to write your own problem. So again, a pretty straightforward problem if you analyze the cases correctly. All right, moving on. The next one is again not a super difficult problem. And here you have to write a function called flatten. Okay, so what this function does is basically, this is a recursive function. So it basically looks at an input which is a cell array which may contain other cell arrays and sort of write all those entries in a single double array. Okay, so the structure of the function itself suggests recursion. So what you have to do here is basically, in this case, the algorithm could be very simply implemented in recursively as follows. You just look at each entry in the input cell array. Okay. Now you can use a for loop for that or do it any other way you want. So if it is a scalar or a double or a number, whatever, then you can just add it to the output. So just add it to the output array. Okay. If not, if it's a cell array, then you can simply call the function again, the same function flatten on that cell array. So call flatten on that cell array to extract its contents and add it to the output array. So if you implement it correctly, it should be done in a very few number of lines of code. I don't want to give an exact number because it can be done in slightly different ways, but it should not be very long. The basic idea is that you look at each input and figure out if it's a cell array. If it's not a cell array, then you just add it to the output array. If it is, then just call the function flatten again on the new cell array and extract its contents and add it to the output. So it's a recursive function, and this is the basic idea behind recursion. So I hope that makes sense. The last one is the best part, is the most fun problem in this assignment. So here you're going to write a code called Pascal's triangle. And again, since this assignment is on induction, you're going to use a sort of a recursive approach to write this function. So what you're asked, so again, let's start off with the discussion of inputs and outputs. So inputs are row and column. Okay, so this basically gives the row and column number for which you want the entry in the Pascal's triangle. So looks like I have to move something because I'm exceeding the limit, so I'm going to have to delete these and delete these and delete these. Okay, so so here you're going to write a left justified Pascal's triangle. Your function is going to create a left justified Pascal's triangle. You can refer to figure 2 in the PDF. Okay, so I discussed what the inputs are, and the output is basically value, which is the value at the location specified by row and column in the Pascal's triangle. Okay, so how would you write this? Now the figure 2 contains a hint of how you can compute the value. So the basic idea is you have to compute value by looking at the value of, by adding the values of the Pascal's triangle in a row above that given entry, above the location interested in, and the column above it and the column to the left of it. Okay, so value is to be computed from basically the value in one row above and same column plus value in one row above and one column to the left. Okay, so to compute these two values on the right hand side, you can again call Pascal's triangle and get those values. So this is the basic idea. Now, where is this likely to fail? So the first place where you can easily see it will fail is if the row is 1. If row is equal to 1, then there's no row above it. So for that you have to, so that's like your base case. And for that you have to explicitly define the value. So the base cases are row equal to 1. Okay. In that case, what's the value? Well, in the first one, you can see that value is equal to 1. Okay. Now, before we get to this, actually, we have to first remember, since you're creating a left justified Pascal's triangle, the values in the sort of the right upper triangle are all zeros. So if the column number is greater than the row number, then you want to just set value equal to 0 because it's a left justified one. So that's the first thing. Now, if row is equal to 1, then value is 1. Okay. The next best base case is what happens if the column number is 1? Then there's no left column to that. So again, if column is 1, then also value is 1. Other than that, it should work in all the cases because for every other entry, you have an upper row and a column to the left of it. So this is how you can basically write the function. So first you test the base cases, test if, so first check if the column is written row, if so return 0, check if the row number is 1, then value is 1, check if the column number is 1, then value is 1, and then you write, otherwise you just write value is equal to the way we have defined here in basic idea by calling Pascal's triangle on one row above same column and one row above one left column. So that is how you use the idea of recursion to very simply write it. So once you've tested your function by the code given in the first snippet on the last page of this assignment, just make sure that you get the right values, and then you can call it with build triangle P to create a centered Pascal's triangle. So that's all there is to this assignment. It's not tremendously challenging, and if you have followed the videos and lectures well, then you should be able to do it with not too much difficulty. So I hope this discussion helped you realize that it's not very challenging and you can do it quite easily. So I'm going to end this recording now and take questions if you have any.